All right, so good afternoon, everybody. For today's class, what you're going to need, have out, if you go to week number 9, okay, the folder for this week, if you haven't printed it out for last class, print out and have handy this standard normal table, okay? Looks like this. How many people have this handy or at least have it loaded up already to go? Okay, good. A few people do. All right, great. So we're going to use this quite a bit for the first problem today. And then also, if you have it handy, okay, please take out either your TI-83 or your TI-84 calculator. I want to show you a really neat trick with it during the after we do a couple by hand. And I know you guys have heard me say this, but you ever notice how like we do a problem by hand and then I'm like, okay, guess what? There's an easier way on your calculator. Well, I'm going to show you the easier way on your calculator. So have it handy as we go through the lecture. Also, your next homework is posted, homework number 4. Just out of curiosity, has anybody taken a look at it yet? Does it not seem too bad? All right, well, go ahead. I'm sorry I cut you off. It shouldn't take too long. Yeah. So the homework, this is one of the shorter homeworks, actually. It's 2 questions, only 3 parts for each question. So it really shouldn't take you too long. It's due next Tuesday, but it's due by 11:59 next Tuesday. So if you want to try it over the weekend and ask me any last minute questions, feel free to. I will tell you this. If you haven't done so, I would literally do this homework right after class today, while it's still fresh in your mind. Because once I show you specifically how to use the graphing calculator today, it's like night and day how easy and quickly you can do these problems. Okay, so I'll plan to take questions on it next Tuesday. If you have any questions, but then you can submit it after class next time. Just out of curiosity, Melissa, how long did the homework take you?
Maybe about a half hour.
Yeah, right. It was. And did you do everything by hand with the table?
Yeah.
And then you're going to be like, oh, why didn't I wait? Because after class today, you'll be like, oh, this is a little bit easier way. But have that handy. And then just looking at the course syllabus, I'll post homework number 5 next week. That's due Thursday the 8th. And then that'll be the day of our next exam. So your homework number 5 will be kind of like a review for the exam. So next week, what we'll do is we'll talk about something called the central limit theorem. And then the week after that, on the 6th, I'll do a review day, and then we'll have exam number 3 on the 8th. All right. And then the course is like moving pretty quick, isn't it? We only have a couple weeks left. Anybody else feel like it's moving really quickly? Yeah, super fast. Summer's going to be here before we know it, which will be good. I'm ready for summer. I'm ready for the semester break to happen. Better come quick. Yeah. Yes, sure, it better. All right. One last time before I get started, any last minute questions? Okay. So last class, what we were doing, we were looking at the normal probability distribution. And all I want to do today is just a bunch of examples with it. Just so like we can hit this home, because next week when we talk about the central limit theorem, it's really just going to be an extension of what we talk about today. So, mastering it today will be is really important. Okay. So I want to do one quick example, and this example is going to be done by hand. Okay. And when I say by hand, what that means is using the standard normal table from last class. All right. So I want to give you a little history on this problem, okay? How many people in here, just in the chat, or you could turn your mic on, how many people have heard of Chips Ahoy chocolate chip cookies?
Of course.
Right?
Yeah.
We've all heard of Chips Ahoy chocolate chip cookies, right? So yeah, I mean, they're really good. They're really good. So I'm a child of the 80s and 90s. That's when my, formative years were. And so they used to have this advertising campaign. And I'm literally curious if anybody remembers this campaign. Unfortunately, if you do remember this campaign, you'll date yourself. Okay. What they used to say, they used to run this campaign where they said there were 1,000 chips in every bag. Right? Do you remember this, Melissa? You posted that in there? Yeah, it used to be a huge marketing campaign. Okay. But you'll notice if you buy Chips Ahoy cookies anymore, I don't know. If you notice, they don't have this campaign anymore. Okay. And so this problem kind of sets up why they don't have this campaign anymore. All right. So the number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate chip cookies is approximately normally distributed. Okay, that's important to see that right there. Okay. So whenever you see the words normally distributed in a problem, you know it's going to be a bell curve problem. Okay. And you're probably going to need to use, if we're going to do it by hand, you're probably going to need to use this table here. Okay. So the next question I have for you guys is, do you think every bag of chocolate Chips Ahoy cookies has the same number of chocolate chips in it? Like every bag has the exact same number of chips? Yeah, like no way, right? Yeah, Alexandra has it. No way. It's a manufacturing process, right? Like they just dump a bunch of chips into a vat and spit them out and make them into cookies. So, it's not likely that every bag has the same number of chips. Okay. So what we're saying here is, look, we realize that there's variation in the number of chips in a bag, and that the number of chips follows this bell curve, this normal distribution. So we're saying that the mean number of chips in a bag is 1,262. That's great. With a standard deviation of 118 chips. And I actually love this next part. And this was according to a study by cadets at the U.S. Air Force Academy. So this professor at the U.S. Air Force Academy needed students to help him count the number of chips in bags. And if you're a cadet at the Air Force Academy, you kind of have to follow orders. So really what happened in this study is they forced these students to count the number of chips in a bag. Don't you think that's kind of funny?
That's brutal.
It is, bro. I mean, what they do is they dissolve the cookies and then they count the chips. So it's not the worst, but yeah, it is brutal. Could you imagine that being well, you guys, this weekend, your homework assignment is count the chips in a bag. It's oh my gosh. All right. So here's the problem. Suppose a bag of 18-ounce Chips Ahoy cookies is selected at random, and the number of chips in a bag is recorded. Okay. So do I, before I count the chips in the bag, do I know how many chips are going to be in that bag that I select? No, right? Before I count it, no. So it's an unknown number. So we're going to define a variable. We're going to let x be equal to the number of chips in a bag. And when I say bag, what I mean is an 18-ounce Chips Ahoy chocolate chip cookies bag, but I'm just going to write bag. I'll just put bag of cookies. Okay. And then here's what else we know from the problem. We know that the number of chips in a bag is approximately or follows a normal distribution. And then they're telling you the mean. is 1262. So on average, there's more than 1,000 chips in the bag. That's great. And the standard deviation is 118 chips. Okay. So now what I'm going to do is I'm going to ask you 2 probability questions. All right. And everybody let me know if it's okay to go to the next slide. And then when we go on break today, you should all go get a chocolate chip cookie. Can I get 1 thumbs up like I'm good to move on? Okay, thanks, guys. All right, so now here's the thing. I told you normally distributed, mean, standard deviation, and now I'm going to ask you for a probability, okay? So what you're going to have to do is you're going to have to follow the process from last class for this. Okay, so what is the probability that the number of chocolate chips in a bag is greater than 1,300? So for some reason, what I'm doing here is I'm asking you, if you grab a random bag off the aisle in the grocery store, what's the probability that you get a super bag and it has more than 1,300 chocolate chips? Okay, so if you remember, I gave you a 4-step process for solving this last class. Can anybody help me out, look back maybe in their notes from last class and tell me what step 1 was? I'll pause and have a sip of my coffee while somebody looks. Nobody wants to say anything?
To write the probability statement.
Thank you. Yep. So you define the variable, we already did it, and write the probability statement. So I want to find the probability that the number of chips in the bag is greater than 1,300. Okay. Does anybody remember what step 2 was now?
Sketch the curve.
Sketch the curve, right? So and listen to me, please, everyone. For as long as I've been teaching, it's this. Whenever somebody makes an error on the problem, it's generally because they didn't sketch the curve. I know it sounds silly, but it helps you remember which process to do. So we know that X is normally distributed. So this is the number of chips in a bag. They follow this bell curve, okay? And it's centered at the mean, okay, which is 1,262. And over here is 1,300. So if I want to be greater than 1,300, am I going to shade to the right or am I going to shade to the left or to the right? To the left or to the right of 1,300?
Right.
Yep. I'll find this red area to the right here. Okay. So now here's the thing. To use this table right here, I need to convert my problem into something using. Does anybody remember what they were called? It started with Z and then ended in something.
Z-scores.
Mm-hmm. Yep, thanks. Values of interest. To Z-scores. So this is the formula. Z-score is equal to X, which is your data value, minus the mean, divided by the standard deviation. So this is my X that I'm interested in right here. It's 1,300 minus the average number of chips in a bag, which is 1,262. And then got to divide by the standard deviation, which is 118 chips. I really encourage you to follow along with me with your calculator here. Also a common error I see. This is just a common error I see. Students go to plug this in their calculator like this. Does anybody see something wrong with this? Why this would give me the wrong answer?
Yeah, last exam, I got something wrong like this. We should
Well,
first finish the minus and then we can
yeah, you need,
What did you
and
do?
thank you, Melissa. Yep, exactly what you said. Melissa has it here. You need to put the numerator in parentheses. So if you're going to do this in one step in your calculator, you have to go 1,300 minus 1,262, close the parentheses, and then divide by 1,800. And you should get this. Okay. Otherwise, if you don't, it reads order of operations. It does division first and then subtraction, right? So you need to put the parentheses there. Okay. Now, does anybody remember how many decimal places the z-score table goes to? So the z-score table gives the probabilities to 4 decimal places, yes, but your z-score should only go to 2 decimal places. Yep. So it's, don't forget the decimal places right there. It's 3 numbers that you're thinking, Melissa, but it's 2 decimal places. So whenever you do a z-score by hand, it's okay. It's all good. All good. You're going to take this and round it to 2 decimal places, which is 0.32. So I'll just put that in parentheses. Round z-scores to 2 decimal places. Always. All right, then finally, step 4. Once you got your z-score, the last thing you need to do is you need to use the table to find the area. Okay. So this becomes, you can even write it like this. This now just becomes, what's the probability a z-score is greater than 3.2? All right, now here's the thing. If you remember from last class, does the table give the area to the right or to the left?
It gives both.
So it only gives to the one of them, but you can use it to find both. Yeah, is what you're saying. Absolutely. So if you look here, you notice how the table has the area shaded to the left, like this. Does anybody remember the procedure for finding the area to the right?
Subtract by 1.
Yep. Okay, so here's what you're going to do. You're going to go 1 minus, and you're going to look this value up on the table. So I'm going to go look up the z-score of 0.32. So what you have to do, it's a positive number, so you use page 2 here. You look up at the first 2 digits of the z-score, 0.3, and then you go to the top, whatever the last place the decimal is, so it was 0.32, so you go find the 2, and you look where they intersect. And you get 0.6255. 0.6255, right there. Does everybody see that? Can I get 1? Yeah, I see it. Yep. Okay, thanks. So it's 1 minus 0.6255. So if you were to plug that in your calculator, 1 minus this, you'd get 0.03 745, I believe. All right, so not the worst, but not the easiest thing. Okay, there's a lot of steps to it. And you can easily make a mistake. All right, how about before I go on to the next question, does anybody have any questions about this problem I just did? All right. So now here's the thing. If there were at least 1,000 chips in every bag, okay, let's suppose it was true, okay, that they put 1,000 chips in every bag, okay, at least 1,000 chips in every bag. What do you think the probability would be of getting a bag and it having less than 1,000 chips? Okay, if their advertising claim was correct. Well, if there was at least 1,000 chips in every bag, could you actually get a bag that had less than 1,000 chips? Well, the answer is no. Like if it was true, there's no way you could get a bag with less than 1,000 chips. Okay. So given this information that we have, let's see if that's true. Okay. So let's find the probability that the number of chocolate chips in a bag is less than 1,000. Okay. So you want to find the probability that X, the number of chips in a bag, is less than 1,000. All right, step 2. I think this is the most important step. All right, we know X, the number of chips in a bag, is normally distributed. We know on average you should get 1,262 chips. And I just want to find the probability that you have less than 1,000. So if it's a less than, you're going to shade to the left here. Okay. What do you do next? What do you guys think?
Convert.
Yep, you convert to z-scores. All right, so your z-score formula is equal to x minus the mean divided by the standard deviation. So this is my x value of interest here. So it's 1,000 minus the mean, which is 1,262, divided by the standard deviation of 118. So grab that trusty calculator. Always remember to put the numerator in parentheses. So it's 1,000 minus 1,262, close the parentheses, divided by 118. And this is what you get. So it's negative 2.22. And then now you're ready to use the table. So it's the probability that a z-score is less than negative 2.22. And so for these left-tailed problems, this is the easiest one you can get, okay? You can just like read this right off the table. So negative 2.2, and then the other digit is another 2. So do you see the answers 0.0132 there? How many people see that with me? Okay.
Yep.
Yep. So that's the answer. 0.0132. All right, so let me ask you this question. Knowing that, is it true? Are there at least 1,000 chips in every bag? Yep.
Yes, maybe a small percentage.
Well, all right, Melissa, why is the answer no, that there's it's not true, okay, that there's not at least 1,000 chips in every bag?
Because there's a probability that it is less than 1,000. It's small,
Yeah.
but it's
Yeah,
probability.
there's a little bit more than a 1% chance that the bag that you grab has less than 1,000 chips. So they lie, you know, that's why they had to stop the campaign. That's why they don't ever say there's 1,000 chips in every bag. So at least you guys don't go to the Air Force Academy and had to do this. All right. So what do you think of this procedure? Is it not too bad? Like, I know it takes a while to do these problems, and a lot, maybe it doesn't take too long. A lot of it is I throw in my color commentary as we do them, but yeah. Okay. All right, good. Good. So what I want to do now is I actually want to make them easier for you. I hope that's okay. I hope everyone's okay with me making it a little bit easier for you.
Make them hard.
No, the reason always okay. Yeah. The reason I do all this stuff is like, you know, statisticians don't do any of this stuff by hand, right? We all, you know, even when I worked in industry, like you just use technology to solve this, but it's good to have an understanding of how this stuff is done behind the scenes. But when we can, let's use technology to help make our lives a little easier. All right, so I want to show you how to do this with the TI graphing calculator. Now, here's the thing. It doesn't matter if you have the TI-83 or TI-84. It's a little bit easier on the TI-84. But I'm just going to show you. I'll show you how to do it on both. So if you have a TI-83, that's okay too. It's not a big deal. And you have this option in your graphing calculator called Normalcdf. All right, so everybody grab your graphing calculator here. Where are you, TI-84? Okay. And actually, let me go back so you don't have the calculators in the background. Do you guys remember, we actually used this button before. So look on your calculator. Does everybody see the DISTR option right there? DISTR, DISTR. How many people see that? DISTR, DISTR. Yeah. We used it when we were doing the binomial problems. So everybody hits second function and then distribution. Okay. Does everybody see option number 2 there called Normalcdf? How many people are with me on that? I got 1, I got 2. Okay, this Normalcdf is going to be like the greatest thing for this course, okay? What the Normalcdf does, okay? For any normally distributed variable, it gives the probability that X is less than some number, okay? So literally what it does is it gives the answer, I'll go back to a second, to this problem right here. The probability that X is less than 1,000. Like it will just solve it for you, okay? So it gives the answer to the probability that X is less than any number. So what this means is if you're going to use this function in your calculator, one, no need to do z-scores. Okay, there's no need to do z-scores whatsoever. And then you don't need the statistical table. Okay, so basically what it cuts out is steps 3 and 4. Like it'll just solve it for you. It'll do all the calculations on the back end. Okay. So this is a function, and you have to input 4 things into the calculator. All right. May I go to the next slide? And let me rephrase that. I kind of misspoke. It doesn't just give area less than. I'm sorry, I misspoke there. It gives probabilities. It actually solves all of them. Sorry, I wasn't thinking there for a second. So I'm going to show you, and I'm going to come right back to this page. I'm going to show you how it answers both this question and this question. I'm sorry about the typo there. My mind was wandering a little bit. My apologies. And let me know when I can go on. It's really like the greatest option we have to solve these. Okay. So the normal CDF requires to input 4 things into the graphing calculator. All right. The lower value and the upper value. I will explain what those are as you do the problems. It asks you to put in the mean, which is that mu, and then the standard deviation. Okay. So the lower is just going to be some number. The upper is just going to be some number. So if you look at your TI-84 or TI-83 here, when you go to number 2 and you hit enter, you have to remember the order to put things in: lower, upper, mean, standard deviation, and you have to use the comma. So it's a little bit more work than if you have the TI-84 and you go to normal CDF. It asks you, it literally says what's the lower, what's the upper, what's the mean, and what's the standard deviation. And then it just allows you, and then it just pastes it for you. So it's a little bit easier. Okay, it's a little bit easier. All right, the way you use this, there's 3 types of probabilities we had. We had a left-tailed probability. That's when your graph looks like this. And you had some left tail shaded like this. Then we had a right-tailed probability. That's when you're drawing or your graph of the problem looks like this. You have something between. And then you have a between probability. Looks something like this. So you're between 2 numbers, A and B. Okay. What I'm going to do is I'm going to explain like what the input is for all of this. And then what I'm going to do before we go to break is I'm going to go back and I'm going to work these 2 problems and show you what the answers are and like how easy it is. Okay. When you have a left-tailed probability, okay, so this is going to be like the probability that X is less than some number. What you're going to plug in, you're going to go normal CDF. And literally what gets plugged in, the lower value, you have to put in some really, really small number. Okay, so what you're going to have to put in is like negative 99999. Okay, so for anything that's a left-tailed, you're going to put in negative 9999999. Okay, then you're going to go comma, and then the upper, so it's going to give the probability, it's going to give all this red shaded area up to whatever the number is. And then you're going to put the mean and then the standard deviation. I know it, like, I realize I just explained that, and how many people are like, this is a little confusing? Because I realize like I might not have explained it the best, but I promise you, after you see like the first 2 examples or so, I promise you, you're going to be like, oh my gosh, that's so easy. Please bear with me. Okay. Now, if it's a right-tailed test, so it's a probability that X is greater than some number, like I have here in picture number 2. You're going to go normal CDF. And what you're going to do is the lower value is the first value that the area is shaded in. Well, it's going to start here with this number, whatever you have put in here. You're going to go number, comma, and then your upper value is going to be everything shaded all the way to the right. So you're going to go 99999. You're going to have to put in some really large number. And then the mean for whatever the problem is, and then the standard deviation. Now, the third type of problem, if I want to find the area between. So it's the probability that your X variable is between 2 numbers. You're going to go normal CDF. And then your lower value is going to be A. And you want to stop at B, so that's your upper value. And then you're going to plug in your mean and your standard deviation. And trust me. I know I say this all the time, but after you work 1 or 2 examples, this is like incredibly easy. So before we go to the break, let me just say, before I start the example, does anybody still need to copy anything? I don't want to jump ahead while people are still copying. Storm tells me they're set. Okay. All right, thank you. Everybody else is like, I'm on Facebook, so that was a joke. That's a joke. There's nothing good on there these days anyways. All right. So what I want to do is I want to rework this problem right here, that it's less than 1,000 chips. We'll start with that one. Okay. So here's the problem. X was normally distributed. The mean number of chips in a bag were 1262. And the standard deviation was 118. So the first question was, what's the probability? Actually, you know what? We'll just do them both. First question was, what's the probability there's more than 1,300 chips? All right, I really think the drawing here really helps. Okay, so I'm going to sketch the drawing. So it's normally distributed. So you're centered at 1262 and you want to be greater than 1300. So you're going to shade to the right. Okay. Do you notice how this problem right here looks a lot like this? And it looks like this right here. Would you guys agree?
Yeah.
Okay. So watch this. You're going to go normal CDF. And the first thing you're going to do when you do this is you're going to say, all right, I need to input a lower number. So what you're going to do is you're going to like, think of this as a number line. Okay. Do you notice how the first number you're interested in is 1300? Do you guys see that that's where the red shaded area starts? I don't know what that means, Storm. Is that a yes or a no? Or like, I'm confused.
It's a yes. It's like a
Okay.
like
Gotcha. Okay. Sorry. So you're going to put 1300. You're going to go comma. And then you notice how the area keeps going? Like, because it's a right-tailed test, it's going to keep going. So that means your upper, because it keeps going, you're going to put something ridiculous, 99999, comma. And then you have to put in, well, what is the mean number of cookies in a bag? And then what is the standard deviation? So watch. I'm going to do it on the TI-83 first, and then we'll go and do it on the TI-84. Yes, I actually have 5 nines there, but if you do 4 nines, there's not going to be any difference. You're going to use 99999 every time, every time, for every problem I give you in this class, at least. Okay, so go second function, distribution, normal CDF. Okay. So now watch on the TI-83. You're going to put in 1300, comma, 99999, comma, the mean 1262, comma, and then the standard deviation 118. And then close the parentheses. The good news is over here, you're going to go, it's going to ask you, it's a little bit easier. What's your lower? What's your upper? What's the mean? And then what's the standard deviation? And then you're just going to go down to paste. And you should see something like this. All right, now everybody hit enter. How many people got what I have on the screen there? Okay. All right, so look, what this is saying is the answer is 0.3737. So if you notice when we did it by hand, we got something, we got 3745. So it's really close, but a little bit different when we did it by hand. Can anybody tell me why this number is different from what we got in the calculator? Well, let me ask this. When we did this by hand, did we have to round a z-score? You notice when we got to the z-score, we had to round it off?
yes.
Yeah, your calculator doesn't do any rounding, okay? It literally just computes the correct answer, okay? So either one is fine, okay? And on the exam, if you're gonna do it by hand or with the calculator, I build in a tolerance so that it accepts either answer. But what do you think? Was this a little bit easier?
I would say so.
Yeah. How many people were like, I don't know.
I just have a question. Like, do you mind, like, on the break going over the calculator part again just one more time?
We're gonna do, that's all we're gonna do during the second half of class, actually.
Awesome. All right.
Yeah, I literally have we're just gonna probably just get through 2 more examples. I'm like gonna hit this home, the calculator. All right, let's just go back and just before the break, just do one more cookie example. So the other question was, what's the probability that the number of cookies or number of chips, excuse me, was less than 1,000 here? Okay, and we got 0.0132. So look, this is why I think the drawing really helps. You're at 1262, and you want to be less than 1,000. So this tells me it looks like problem number 1 here. Okay, and look, X is less than 1,000. X is less than a number. So you're going to go normal CDF. You have to put the lower value in. So do you notice how like this is a tail area all the way off to the left? So you have to pick something way away from 1,000 because you have to go all the way to the left. And that's why I say pick negative 9999999. And then where does your upper value, where does it tell you to stop finding the area? At what number here? Like where does the red area stop?
1,000.
Yep, and that would be your upper. And then you're going to put in the same mean. It's 1262, comma 118. So if you have the TI-83, you just have to go second function distribution, normal CDF. Now, when you go to put in a negative number, does everybody see where my mouse is on the screen? Can you guys see my mouse? People see my mouse? Storm says yes. You go negative here, negative 99999, comma, stop at 1,000, comma, 1262, comma, 118. And how many people got this on their calculator? Yep. And look, if you do the TI-84, you get the same thing. So you got to go negative 99999, 1,000. And look, you get the same thing. And when you round to 4 decimal places, you get 0.0132. Boom, we got it. All right, so how many people think this might be a little bit easier than doing it by hand? It's much faster. Yeah. Melissa, unfortunately, if you had waited, your homework would have taken you 5 minutes. But I know, just wanted to let you know. And so I'm going to take a break now. We'll take a break for 10 minutes or so. And you are more than welcome. Listen to this. You are more than welcome to use this on the exam and on your homework. Okay. The only thing I ask is if you're going to do this on your homework, that you write out this normal CDF, like what you plug into your calculator. That way, if you make a wrong mistake, I can see where it is. Okay. All right. So let's take a break and let's be back at 2 p.m. All right. All right, everybody. I'll see you in 10 minutes unless there's any last minute questions. Okay. I'll be back at 2 p.m. All right. Can everybody hear me okay? You guys hear me okay? Okay, good. Thanks. Thanks. Okay, so what I want to do is I think I just want to get through these two examples here. And what I want to do is I want to work the first one with you, and then I want to do something I haven't done in a while. I want to give you guys a chance to try the second one. I'll be quiet for maybe 5-10 minutes, and then we'll come back and I'll show you the answer. So let's try something a little different today. All right. So for all these examples, what I want to do is I want to show using the graphing calculator. Okay. So here's the first problem. So the length of human pregnancy, so that's the gestation period, is approximately normally distributed. Okay. So like, not every baby comes on the same, it's not always exactly 9 months, right? Like my son came, I think 7-8 days past his due date. So not, it's just normally distributed. Okay. So, most babies come around their due dates, some babies, but not that many come way late and some come way early. So they're saying that the average time is 266 days and the standard deviation is 16 days. Okay. So I'm giving you those. So this is important. Normally distributed, you're getting the mean and standard deviation. And then I'm going to ask you for a probability. All right, so here's the first one. What is the probability that a randomly selected pregnancy lasts less than 260 days? So look, when you do this by using your graphing calculator, you're still going to need to do these steps. Okay, so the first thing you're going to need to do is define the variable, which I do here. Okay, so if I just select a pregnancy at random, say that there's this database of all the babies born last year. Okay, and we're just going to grab one of those pregnancy lengths at random. Okay, so we don't know what it's going to be until we get the answer. But so I'm just asking, well, hey, what's the probability that it's less than 260? So let's let X, okay, be the length of a randomly selected pregnancy. So we define the variable. The second thing you're going to do is you're still going to write the probability statement. Okay, so this is the probability that pregnancy is less than 260 days. Okay. What do you guys think? What do I always say is the most important thing? I know I joke around about this, but what do I always say is the most important thing?
The sketch.
The curve, right? Like, please, like, trust me on this one. Like, especially when you go like take your exam, just like take 2 minutes to sketch it out, because the curve really tells you like how the problem is going to be tackled. So the third thing you're going to do is you're going to sketch curve and shade in area you're looking for. Okay. So lengths of human pregnancies, they follow this bell curve. So on average, the average one is 266 days. And I just want to find the probability that this pregnancy is less than 260 days. So here's 260. And if I want to be less than, I'm going to shade to the left. All right, once you do that, the fourth thing you're going to do is you're going to use the Normalcdf in the calculator. Okay, so we're going to have to put in 4 things here. The first thing you're going to have to put in is a lower value. Okay. So when you're a left-tailed test, as you go left to right, like what number for a left-tailed, I said left-tailed test, sorry, I was getting ahead of myself. A left-tailed probability, you know, as you go to the left, what did I say the lower number was to put in?
-9999.
Yeah. And look, if you're ever like unsure, just go back in your notes to right here. Okay, it's a less than, a left-tailed probability. So my lower is going to be -9999999. Comma. And then the upper is where the probability, where the area stops. So what number am I telling you to stop at?
260.
Mm-hmm. And then you're going to plug in the mean, which will be given. And then you'll plug in the standard deviation, which will also be given. So everybody grab those trusty calculators you have. So second function distribution, normal CDF. Second function distribution, normal CDF. Okay, so lower, you're going to go -99999, comma. I'm going to stop at 260, comma. The average is 266, comma, and then the standard deviation was 16. So over here again, -9999. When you press enter on your calculator, right, how many of you get that answer that's on the screen there? All right, I got one, I do. I remember when my wife said that. It was the happiest day of my life. Aw. Anybody else? Yep, okay. Yep, thank you. All right, so we got it. We got it. All right. So it looks like it's 0.3538. All right, so we get lower, upper, the mean, and then the standard deviation. All right, so now you've seen me use the calculator a few times. Is it like, is it pretty straightforward, do you think? Are you getting like used to it? You know, I think Melissa says, I think so. How many, I'm just curious, how many people like think it's a little bit easier?
I think so.
Easier to use the calculator?
Yes.
Yeah, I think it's easier to.
Yeah. Yeah. I just think this is just a weird anecdotal thing that I wanted to share with you guys anyways. But like for as long as I've been teaching this class, you know, when I first like got into teaching, like cell phones and like mobile technology wasn't like that big of a thing. But like as time has gone on, like people have gotten really good at using technology. And like when you have to do something like follow these steps, look something up on a table, like it's doable, but it's just, you know, so much easier. And people are so used to like technology that this stuff people catch on to really, really quickly. I find. Just to, I don't know why I wanted to share that, but that's just an interesting observation of my academic career. Yep, doing it by hand help. Yep, totally. There's just steps to it. And like some people do like it by hand, right? Because like there's definitive steps, like do this, do this, do this, and follow it along. All right, let's do the next two. Okay. So what is the probability that a randomly selected pregnancy lasts more than 272 days? So it's the probability that X is greater. So because it's more, it's going to be greater than 272 days. So you should be, average pregnancy lasts 266 days, but I want to find the probability that it's greater than 272. Like this. Okay, so this is a right-tailed probability because I've got this area shaded off to the right. So again, I wrote the probability statement, I've sketched it. So we're going to go normal CDF. And it's always the same things. Lower, comma the upper, comma the mean, comma the standard deviation. All right, so in this case, all right, what's my lower value? Like where does the red area I'm looking for start in?
72.
Yep, 272. And now it's a right-tailed. So if you look back here, if you go back into the notes, go back a few slides. When you have a red shaded area to the right, what like upper number do you put in?
9999.
999999. Yep. And then look, then you just put the mean in, which was 266 days, and then you just put the standard deviation, which was 16 days. So normal CDF, 272, comma 999999, comma 266, comma 16. And if you have the TI-84, it's pretty straightforward too. How many people got this? It actually is the same probability. So 0.3538. And that's because the reason it's the same probability, because if you look at it, it's less than 6 days from the mean, more than 6 days from the mean on both sides. So that it actually should be the same probability. All right, last question here for this one. What is the probability that a randomly selected pregnancy lasts between, so now it's between 260 and 280 days? So look, I know it seems silly, but I really find that the drawing helps. So 266, so I want to be between 260 and 280. So I want to find all this stuff in between. Okay, so again, normal CDF. What's my lower here?
260.
Yep, because it starts at 260. And then what's my upper?
280.
Mm-hmm. And then mean, and then standard deviation. So I'll do it on the TI-84 this time. So it's going to go 260 to 280, 266, 16 is already saved in there. And then how many people got this one right here? Good, Alexander, thank you. Thank you. Yep, awesome. So it's 0.4554 when I round it to 3 decimal places, 0.4554. Calculator, loving it. I hope so.
Loving it.
Best investment. Yeah. It's great. You know, it's a really great tool. All right. So let me, anybody still need to copy before I go to the next one? Everybody good?
I am.
Okay. Sorry about that. Let's go to the next one here. Okay, so here's what I want to do. It is 2:17. I want to give you maybe 5-6 minutes, okay, on your own. Okay, I haven't done this in a while, to just give this a shot. Okay, and if you please, don't zone out and just wait for me. Even if you don't have a calculator here, like at least, if you don't have your calculator handy, at least write out like normal CDF what you think they are. Okay, because look, I'll be honest with you. If you can do this problem here, you can handle everything that's on the upcoming exam, basically. Okay, so trust me. Give this a shot. So everybody, it's 2:18. Let's try on your own until 2:23. So I'll give you 6 minutes to try on your own. Does that sound okay with everybody?
Yeah.
Just see if you could set it up. All right. So I'm gonna turn my mic off. And you guys, if you have any questions, I'll be here. But at least try to set them up. Let's try to set them up. All right, just out of curiosity, how many people found the calculator really, really easy to tackle these problems?
I'm still having a little problems with my calculator. Like just understanding and just following the process, but I should be all right.
What do you think is the trouble with your calculator? Is it like just what numbers to plug in where?
Yes, because once you hit the dister, like DISTR, and then go to 2, like once you give me like once I have the upper and lower come up, it's just like I get kind of confused of what's entered right there.
Sure. Okay. So let's go through this. Just out of curiosity, do you have a TI-83 or TI-84?
TI-84,
So you have this one right here.
correct.
Okay. All right. So here's the problem. A packing plant fills bags with cement. Great. Okay. And so it's a manufacturing process. So what's going on here is they're saying, look, not every bag is exactly the same amount of cement in it. Okay. So the weights of the bags of cement follow a normal distribution. Okay. With the average weight of 50 kilograms per bag with a standard deviation of 2 kilograms. Okay. So suppose a bag of cement is selected at random. So we're going to define this variable. We're going to let X be the weight of a randomly selected bag of cement. And here's what else we know. We know X is normally distributed. And then it gives us the mean. So the mean is 50 kilograms. And then it gives us the standard deviation of 2 kilograms. All right. What is the probability? What is the probability the bag weighs less than 49.5 kilograms? So it's the probability that X, this bag, weighs less than 49.5. So look, I really think that the drawing helps. I don't know if other people feel this way, but that's just me. So you should be at 50. And for whatever reason, we want to know whether the bag is less than 49.5. So I'm going to shade to the left because it's a less than. Okay. So you're going to go normal CDF. First thing you're going to plug in is the lower. All right, can anybody tell me what the lower value is here for this left-tailed here?
Negative 99999.
Yep, negative 99999. And then what is the upper I'm going to plug in?
49.5.
49.5, yeah. And then you're going to go comma, and then you're going to plug in the mean. So what was the mean? What was the average bag? How much does the average bag weigh?
50.
Mm-hmm. And then you're going to plug in the standard deviation, which was 2.
It's like just the lower and the upper keeps changing. The rest, the mean and the distribution is always the same.
That is correct. Yeah, from problem to problem, the only thing that's going to change is the upper and lower, but the mean and standard deviation stay the same. So look, you're going to go second function distribution. You go down to number 2 if you have a TI-84, and the lower is negative 99999. The upper here is 49.5. Here the mean is 50. And the standard deviation is 2. So for after the upper and lower, it's always whatever the mean and standard deviation is. And that will always be given in these problems. And if you did this, how many people got this number right here? 0.4013 when I round it to 4 decimal places. Awesome. Good. 0.4013. Great. All right, so now let's do the next two. So what is the probability the bag weighs more than 53 kilograms? So it's the probability that this randomly selected bag is super heavy, 53. So you're still at 50. And for whatever reason, we want to be greater than 53. So we're going to shade to the right because it's a greater than. So this is normal CDF. In this case, what's my lower value here?
Same number, -999.
So here's the thing. Now it's to the right.
Right. So would it be 53?
Do you see the, so the way, here's another way to think about this, okay? And maybe this helps. Think of these curves as like a number line, okay? And imagine, I know this seems so silly, but like imagine that you're gonna walk across the area, right? So like as you're walking left to right, to get this right-tailed, or excuse me, this left-tailed, you have to start at -999 and then you stop here. But if you were gonna walk across the red shaded area here, where does the red shaded area start?
On the right side.
Yep, but what number is my like going over here?
53.
Yeah, it starts at 53 now. And then what's my upper? Like where am I going to keep walking to? Here I would put 99999. And then the mean is still 50. And the standard deviation is still 2.
So the roles just switch.
That's correct. Yep. And notice how over here it has to be negative, but over here it's positive.
Yes.
Yep. And that's it. And then absolutely the roles just switched on this one. So second function distribution, normal CDF. Here you're starting at 53. You're going 99999, 50, comma 2. Close the parentheses. And you should get this. It should be 0.0668. Okay, how many people got this same exact number here?
Okay, so that's 0.0666. That's the z-score.
No, that's the probability. The z-score for this would have been something like 1.5.
Okay.
Yeah. No, this skips the whole z-score. This doesn't give the z-score. It just goes straight to the answer. Yep.
Okay. All right. Thank you.
Yep. 0.0668. All right. So now what is the probability the bag weighs between? Okay. So between 49 and 53. So you're centered at 50, and I want to be between 49 and 53. None of this is drawn to scale. This graph just like literally just helps me figure out how to do this. So normal CDF. What's my lower? Like, I know, think of that guy who's walking across the area. That person. What's my lower when I have a between?
49.
Yep. What's my upper here?
53.
That's it. Yep.
Yeah.
And then you're going to go 50, comma 2, because the mean and standard deviation don't change. So second function distribution, you're going to go normal CDF. So it's 49 to 53, 50, and then 2. And you should get this 0.6247 when I round to 4 decimal places. So 0.6247. So listen, you're more than welcome to do this with the Z-score stuff. But I think the calculator just like,
I'll try it again with that. I want to use the calculator.
use the calculator, trust me. The calculator's less steps, and once you master the calculator is like, it's just like, it just makes everything easier. All right, let me stop the recording.